Okay, so Nvidia just released their new VLA model and trajectory planning. Um, and yeah, I don't know. They talked a lot about it at CES. Well, actually, they released it before CES, and then they blew it up and launched more stuff, whatever, about it at CES. So I was just going through and trying to get this stuff to run in Colab, which it's pretty easy because they already have a notebook, but there's just some changes that you need to make. Um, that's for setting up the sim. That's also for setting up the sim. Yeah, so you can pretty much just go through, clone the repo, and then set up the environment, and then authenticate it. The only difference is just some of the environment commands. I found out the easiest way to do this was just clone the repo and then change your directory, and then just change your then just like update your path that way. I think that's probably easier. And then instead of using the commands that it says, instead of it gives you commands for activating the environment, just running the equivalent bash commands, and then installing all the packages. And then so for their code, they use this media pi library, which actually did not. Well, one, you had to install this library, but then it also had a FFM. I had a FFM like dependency, codependency as well. So I had to. There was some other dependency that I had to uninstall, and then I had to reinstall this for some reason. There was some conflicting issue, and then I went through and just pretty much everything else was just copied. But this is actually pretty. I think this is pretty cool. I would really like to do. So yeah, they gave us notebook, and then they didn't show the output. So if you're, I went through and I just ran all this. It didn't take that long. I had to run this on again. I had to run this on an A100 collab because when I ran locally on GPU, I immediately ran out of CUDA. I immediately ran out of memory. Um. So yeah, I just went. So this right now, this is just generating one trajectory sample. That was just the easiest thing to run. But so this is a chain of reasoning model. So performs it performs reasoning. It's so inference time is supposed to be faster with this. It says in the paper it's supposed to be 99 milliseconds because this is not a fully auto-regressive model. So it's not generating every single token. And it also, so Waymo has Waymo has their whole sensor suite. Okay, Waymo does world reconstruction. So Waymo does fully reconstruction of their environments. This is not that. It does not know. It doesn't know what the objects are. It just performs the reasoning of what they mean. Yeah, and then they do fusion at the camera level, and according to the paper, they essentially process all the cameras together in a single scene. It's kind of I guess it's a triplane essentially, and then they do tokenization from there. And yeah, these are just the different images, and then so this is their message, and it's nudged to the left to increase clearance from construction cones, encroaching on the lane. And yeah, as you can see, that's pretty accurate. This is I guess this is the front view. You can see the construction cone right there, and this is all their code. This is just projected trajectory and then ground truth trajectory. I mean, that's pretty spot on. This is pretty cool. I definitely want to go through and play around with this some. I really want to get the simulator running. I was trying to do some work for that, but I ran into some problems. So that should be really cool if I can do some work for that. And then I mean, I want to look into the idea of, I want to look more into the quantization of the doing more quantization with the weights. I also want to look into the idea of doing LoRa, so like low rank approximation at both the vision encoder, and then also looking at that at the levels where fusion is occurring, and then looking at that at the attention level to see. to see what we can do there to decrease inference time as well, because I think some more work could be done there. So yeah, this is just yeah, but I don't know. I just thought it was interesting to see what the output actually was, because inside of here they show their notebook and they show this, but then they don't actually run the they don't actually visualize the results. So if you're curious for what the results look like, yes, it actually is able to make a somewhat accurate prediction.